folks, let's take a look at example 7. So in this case, instead of giving us two ordered pairs directly, they did give us one, all right, but they're saying, can you find that exponential equation, right? And we're always wondering about a times b to the x, where a is our initial value, which I can see right here with root 2, and then b is either our growth rate or our decay rate. And as I move left to right, I can see I'm increasing, so this is exponential growth. So I'm going to find a b value. We'll get it in a moment, but it's got to be greater than 1 because this is exponential growth. So for me, I can see I'm going to look for 2 points. They gave me 1. Let me rewrite this. It's 0, root 2. And then I want to look for a grid point. I want to kind of make my life easier. And as I look at a grid point, I think I'm seeing 1, 2. So I'm going to head over here and I'm going to take a look at that point 1, 2. Okay, so as I kind of zoom in, not zoom in, but as I look at that, we've got 0, root 2 and 1, 2. Okay, and because this is nice, right? Because I had an initial x value of 0, I immediately know my a value is root 2. So I can simplify this a little bit. I know f of x is now root 2 b to the x. I don't know what b is yet, but I can use this ordered pair to figure that out, because when x is 1, f of x is 2, right? So I'm going to replace this with a 2, and I'm going to replace this with a 1. So let's go ahead and fill in the ordered pair 1, 2. So this is going to be 2 equals the square root of 2 times b to the 1. Okay, well, I can solve for b, and then I'll pretty much be done, but there's going to be some fun arithmetic to do. All right, so I'm going to divide both sides by the square root of 2. Right, this cancels out. Now I'm going to write it with my variable on the left side. So I have b equaling 2 over the square root of 2. And depending on what you feel more comfortable with, there's a couple of ways to go about this. So some folks might see this as this is 2 to the 1 power in the numerator and 2 to the 1/2 power in the denominator. And when you have a power over a power, you can subtract exponents. So you'll get 2 to the 1 minus 1/2, and 1 minus 1/2 is 1/2, which is just the square root of 2. All right, so that's one way we can find out b is equal to the square root of 2. Totally legit. If you like that, keep it. I'm going to scooch this up just a wee bit. All right, some people are going to take 2 over root 2, and they're going to say, well, you know what? I can't have a radical in the denominator. Ooh, let me separate this just so you can see the other way. And they're going to multiply top and bottom by root 2 over root 2. Because when you multiply any number by 1, you don't actually change it. 1 is the multiplicative identity. Anything times 1 is still itself. All right, on the numerator, I'm going to have 2 root 2. And on the denominator, root 2 times root 2 is 2. These 2's cancel, and it leaves you with root 2. So either way you get to the square root of 2, just depends on which way you like best. So I'm going to go ahead and put a root 2 here now, right? I have a root 2 and then root 2 to the x. So again, I'm going to scooch this up just so we can start to see it. All right, and let me see if I got that. I think relatively even. Okay, so at this point, I know f of x is the square root of 2 times the square root of 2 to the x. Okay, but we have 2 powers of the same base, right? This is technically root 2 to the 1, root 2 to the x. So if I have 2 powers, right, same base, I can add the exponent. So this is going to be root 2 to the 1 plus x. So as I start to look at my end game answer, I would say f of x is the square root of 2 to the 1 plus x. All right, thanks so much, everyone. Bye.